In section 6.2, we can either work these problems with the tables or with a calculator. Of course, I prefer the calculator. It's more accurate and quicker, but I'll do a little bit of both here. Now, in all these problems in 6.2, we're interested in three things: the sample size, N, the probability of success, P, and the number that meet our requirement, X. So in this case, it says we found that 45% of adults in a country. That means that's a probability of success, right? 45 of them feel some way. A survey of a random sample of 20 is conducted. That's a sample size. And we're asked the following questions. Find probabilities related to different situations. In this case, that exactly 13 feel that the state of morals is poor. So as soon as you find your N, your P, your X, you're ready to go. You just have to decide how you care about this X. And in this case, we want exactly 13. The probability that X is exactly 13 out of this situation. Real quick from the table, you click the binomial PDF table. Be really glad that your pen is all over the place. Our sample size is 20. That's down here. Our probability of success is 0.45, that's this column. The sample size 20, and the X value we want is 13. So right under here, you look for the intersection of all that business, and we find that the probability of X equals 13 is exactly 0.0366 from this table reading. That's where all the stuff from this problem intersected. If you want to do it from the calculator, you don't have to read the whole table. We do have to find the distribution in the calculator. So on the calculator, we'll use what we call the binomial PDF, probability distribution function. It's pre-programmed to give you back the table values there. A little more accurate than the table values. That's in the distribution menu, second variables, accesses distributions. We'll use normal in the next chapter. In this chapter, we are in binomial. There are two: PDF for exact, CDF for cumulative or less than or equal to. So we want the PDF exactly 13. There are 20 trials, a probability of success of 0.45, and an X value of 13. If you don't get that input menu, you'll put it in just the same way. You just won't be asking you for the stuff. The things you put in first are the sample size, then the probability of success, and then the X value. So that's how your screen will look, just like the screen is right now if you don't have the input menu. Then press enter. Only one time. You see that the calculator answer is 0.0366. They are exactly the same, so we got the right answer two different ways. The next part of the question asks us to find the probability that no more than 8 of those surveyed feel the state of morals is poor. Remember, our sample size is 20. The probability of success, people feeling that morals are poor, 0.45, and the X value we're interested in is 8, but it's not equal to 8 anymore like it was in part A. Part A was exactly 8. Now we are no more than 8, less than or equal to 8. What we would like now to find is the probability that X is less than or equal to 8. What you could do is figure out the probability that X is 0 and add the probability that X is 1 and add and add and add until you get to 8. That would be a lot of calculations of the PDF up here in the calculator, many of them, or a whole lot of reading from the table. Or you can use a built-in calculator function called the binomial CDF. The binomial cumulative distribution function. Cumulative, it adds up those probabilities for you up to the X value. And remember, the inputs there are going to be the same order as they were before. The sample size, N, probability of success, 0.45, and the X value, 8. That will add up. CDF does all this stuff until that number that you put in. Still in the distribution menu, second distribution, scroll down to binomial. Now choose CDF, cumulative distribution function, put in the trials, the probability of success, and the x value. To get the probability here to be 0.4143 from the calculator. If you're doing it from the table, you won't be provided a cumulative table on the exam, so go from here, the binomial table. Remember our sample size was 20. Let's see if I can pull it up here. Get it out of the way. Nope. Okay, so probably x less than or equal to 8. We have 4143 on the calculator there. Our probability of success is still 0.45, so we're still in this column. And this blue sample size bit, which is right under my n equals 20. And now you want less than or equal to 8. So see how these numbers from 0 to 8 right there, kind of where I accidentally put that squash line anyway. 0 to 8 right here. You'd want to add these guys up. That's the probability of 0 plus 1 plus 2 plus 3 plus 4 plus yada yada. Let's see what we get there. That would be 0 plus 0.0001 plus 0.0008 plus 0.004 plus 0.0139 plus 0.0365 plus 0.0746 plus 0.1221 plus 0.1623. And I did it all right because I get the same value as we did from the calculator, 0.4143. That's the cumulative probability less than or equal to 8. The next question is a level up for us. Remember, our sample size still 20, probability of success still 0.45. Now we want the probability that more than 16 feel this way. So x needs to be more than 16. That's our probability statement. The probability that x is greater than 16. And again, you have choices. If x is greater than 16, this is the probability that x is 17 or 18 or 19 or 20. Because there's 20 in our sample. So we have these 4 cases. From the binomial probability distribution table right here, you find where x is 20. We talked already about being in this column. And then we want the cases that we care about. So if we scroll down a little bit, I want from 16 to 20. Scroll up a little bit. There we go. See here, 16 to 20. So we care about these probabilities and that probability of success. From these guys, that's 0.0013 plus 0.0002 for the probability, so 0.0015 if we use the table. Now alternatively, we could look at this in a different way using the calculator, but remembering the limitations of what the calculator can do. So what did we decide this thing was from the table? 0.0015. The calculator only adds stuff up. So we want to add stuff up until 16, but we want the other side of 16. So here's where we use that at least idea. We want the probabilities that are bigger than x equals 16. So 1, that's the probability of everything, minus the probabilities that are not included here. See how we started at 17? So x less than or equal to 16 was missing, or not what we wanted. So we want 1 minus the binomial CDF to 16. N, P, x to 16. Get rid of all those probabilities, 16 and before, to give us the probabilities that are left over. So 1 minus the distribution menu down to the CDF. Sample size still 20, probability of success still 0.45, x value 16. The calculator gives back 2.77 e to the minus 4, which is 2.77, and you take that point and that decimal and go to the left 4 times. 1, 2, 3, 4, and fill it in with 0. So 0.0002 is the probability we get. You see if you rounded 1, 2, 3, 4. If we rounded this guy, he's not the same as this guy. So then we think, okay, gee, what do we do differently? I think with our table we added up from 16 to 20, but we didn't want 16. So let's go back to the table and see, because this answer matches just that second part. In the table here, I can't see anything because it's all blocked up. Nice. In the table, this 0.13 is from 16, so this is the 17 and the 18. That's the actual bit. I should not have used 16 from before. We can put this answer in. What do we do? 0.0002. Oh. Round that baby. 277 turns into 3. Okay, so then we would expect none, because that's very rare. And the last one. Okay, this last one I can see how it'd be tricky. We want the probability that x is 11 or 12. So this leans on the chapter 5 bits about probability, basic probability theory, or means addition. So we are trying to find out the probability that x equals 11, or, which means plus, the probability that x equals 12. So 2 ways we could do this, again in the calculator. It'd be the binomial PDF this time, exactly 11 for n, 20, probability of success, 0.45, and 11, plus the binomial PDF for n, 20, probability of success, 0.45, and we want 12. Or back in the problem here, since we'd be happy with either of them, 11 or 12, when we read the table again one last time, here's 11 or 12 in the sample size of 20. We just have to find out where our 0.45 was here and go back. So we highlight the 11 or 12. We have those two values, 0.1185 or 0.0727. It's 0.1912. And that's the same thing we get from the binomial PDFs here in the distribution menu. Binomial PDF 20 trials, 0.45 for the probability of success, and the x value is 11, plus another one. Binomial PDF 20.45 and 12. Put those babies together, 0.1912 or 13. The software should take either answer. Let's make sure we're right about that. Or 0.191. is what I got from the table, or 1/3 from the calculator. Okay, so would it be unusual to find 19 or more? Well, what's the probability of that? Is it high or low? The probability of 11 or 12. 19 or more. Let's find the probability of 19 or more. One last time. We can look at the probability distribution here. 19 or more means 19 or 20. Here's our 0.45 column again. 19 or 20 is here. 0. Highly unlikely. The 19 or more over here, maybe you do the PDF. For 19, that's e to the minus 6. That's very unusual, and you could even add to that the PDF for 20. In the same vein, the same thinking as we did with the 11 and 12, also e to the minus 6. We only changed a little tiny bit there in that 7th decimal place. So we'd say no, because this probability is very low. Is it unusual? Yes, because the probability is very low. No, we would not expect to see that. Phew.